Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The heat of hydrogenation, ΔH_HYD, measures the stability of an alkene. More stable alkenes release less heat upon hydrogenation, lower ΔH_HYD, while less stable alkenes release more heat. The stability order of alkenes follows Zaitsev substitution rules. More substituted, more alkyl groups on the double bond is equal to more stable is equal to less heat evolved. Exocyclic double bonds are generally less stable than endocyclic ones with equivalent substitution due to ring strain considerations, and terminal exocyclic alkenes are less stable than internal ones. Step 1. Identify the degree of substitution and type of each alkene. A. 3,6-dimethylcyclohex 1-Na. The double bond has one direct methyl substituent on one sp2 carbon and one methyl on the adjacent sp3 carbon. This is a disubstituted endocyclic alkene, monosubstituted on the double bond carbons if counting only direct substituents on the C is equal to C. 1 methyl on 1 vinyl carbon, the ring provides two substituents. Overall, trisubstituted or disubstituted endocyclic. B. 1,6-dimethylcyclohex 2-Na or equivalent. The double bond is between C1 and C2 of the ring, with methyl groups on adjacent carbons, trisubstituted endocyclic alkene. C. 1,2-dimethylcyclohex 1-Na. Both carbons of the endocyclic double bond bear methyl groups. This is a tetrasubstituted or highly substituted endocyclic alkene, making it the most stable endocyclic alkene here. D. 1-methylmethylcyclohexane, exocyclic double bond. The double bond is exocyclic, is equal to CH2, which is less stable than an endocyclic double bond of similar substitution. This is essentially a 1,1-disubstituted exocyclic alkene, but exocyclic alkenes are destabilized relative to endocyclic ones. Step 2. Stability ranking. Most stable, least heat to most heat evolved. Most stable, least heat. C. Tetrasubstituted highly substituted endocyclic. B. Trisubstituted endocyclic. A. Disubstituted less substituted endocyclic. D. Exocyclic, least stable, most heat evolved. Step 3. Heat of hydrogenation order. Most heat to least heat is equal to decreasing. DACB. This matches option B. DACB. Step 4. Why other options fail? A. BCAD. Incorrect because D. Exocyclic should evolve the most heat, not B. C. DCAB. Incorrect ordering of the endocyclic alkenes. C is more substituted than B, so C should evolve less heat than B. D. CBCD contains a repeated letter and is inconsistent. Therefore, the correct answer is B. Therefore, the correct answer is option B.